Think about the objects you use every day. A glass cup is incredibly difficult to scratch, but if you drop it on the kitchen floor, it shatters into pieces. On the other hand, a metal spoon bounces right off the tile, but you can easily scratch it with a butter knife. This is one of the strictest rules in material science. If something is extremely hard, it is almost always incredibly brittle. You can have scratch resistance, or you can have impact resistance. You usually don't get both. Now, imagine the headache of designing a high-end watch. It lives on your wrist, right in the line of fire for accidental bumps against doorways and desk corners. A watch needs to survive the physical chaos of daily life without ever showing a single scratch. Decades ago, the watchmakers at Rado looked at that unbreakable rule of physics and decided to find a workaround. Instead of relying on traditional metals, they turned to high-tech materials, the kind of science usually reserved for aerospace engineering. They found a way to bridge the gap between those two opposite properties, creating a case that balances hardness with toughness right there on your wrist. In this old photograph of traditional watchmakers at a workbench, you see how watches are normally made, carving small, intricate parts from solid metal blocks. Rado does things a bit differently. They don't start with a solid block at all. They start with a pile of microscopic ceramic powder. First, they take that fine powder, mix it with a temporary glue, and press it into a mold. At this stage, the material is about as fragile as a stick of chalk. To turn that fragile chalk into a watch case, it goes into an industrial kiln. The temperatures inside reach well over 1400 degrees Celsius. Let's look at exactly what that extreme heat is doing. This diagram shows how the baking process forces those loose powder particles to physically bond together, squeezing out all the empty space. As those atomic gaps close, the entire watch case violently shrinks by nearly 30%. Getting this right takes incredible mathematical precision. The engineers have to calculate exactly how much the powder will contract, so that when it stops shrinking, it lands precisely inside a grid of tiny specific measurements, perfectly aligning with all the miniature gears. Surviving that chaotic reduction in the furnace is what packs the ceramic together tightly, creating an ultra-dense material ready to withstand the outside world. To actually measure how dense and resilient this baked material is, scientists rely on a laboratory standard known as the Vickers hardness test. Take a look at this diagram of the test. A machine pushes a microscopic diamond pyramid down into the surface of a material using a very specific amount of weight. When the diamond pulls away, the machine measures the crater. Under a microscope, standard steel leaves a massive, obvious crater. But when you apply the exact same pressure to Rado ceramic, the material fights back so fiercely that the diamond leaves a mark so small it is nearly invisible. Since a diamond under high pressure barely leaves a mark, hazards like keys or desk corners simply lack the hardness to damage the surface. But remember our glass cup from earlier. Because this ceramic is incredibly hard, dropping it onto a tile floor should cause it to instantly shatter. To fix this, scientists mix a trace element called yttrium into the ceramic powder before baking. This creates a dormant chemical defense system locked inside. Let's look at this diagram to see what happens at the microscopic level. When the watch hits the floor, the shock wave strikes and a microscopic crack starts to slice through the internal crystal structure. This is where that dormant defense system wakes up. The intense force of the spreading crack triggers a phase transformation, causing crystals right at the tip to instantly swell. These swelling crystals act like deploying airbags. By violently expanding, they squeeze tightly against each other, literally pinching the crack totally shut before it can travel further. This microscopic, shape-shifting maneuver overcomes the natural brittleness of hard materials, allowing the watch to stay scratch-free while gaining internal protection against impacts. Mastering chaotic 1400-degree thermal shrinkage and engineering microscopic, shape-shifting crystal defenses requires immense scientific discipline. But when you look at the final product, you don't see the equations or the industrial kilns. You just see a pristine, beautiful watch that doubles as a masterclass in modern materials engineering. A luxury watch looks beautiful on the day you buy it. By harnessing the unique properties of ceramics, Rado created a timepiece that keeps its showroom shine for decades.